A second type of reaction that you might run into to be on the lookout for is look for one where there's just a single reactant. This type of reaction is known as a decomposition reaction. If there's only one reactant, the only thing you can do is break it up. So you're going to basically do the opposite of a synthesis or combination reaction. You're going to split things. So how do you make something decompose? Depending on the chemical, you might expose it to light. Hydrogen peroxide, for example, is a chemical that just upon being in the presence of bright light, it can cause decomposition to occur. That's why hydrogen peroxide is often sold in a dark brown bottle, if you were to buy it at a grocery store, to help slow down that rate of decomposition that would just naturally occur all on its own. Another way to cause decomposition to happen is to heat up the substance. That kind of loosens up the bonds a little bit and allows the substance to decompose into smaller substances. And just something to kind of take note of here, the verb heated, when you see that, is different than the verb burned. Heat implies some kind of decomposition reaction is going on, while burned implies some kind of combustion thing is happening. When you see a triangle over an arrow, that's sometimes a sign, like this guy right here, that something is being heated. So you could take that ammonium carbonate. The ammonium carbonate will decompose, break down into some smaller substances. Kind of a good thing to be on the lookout for when you're decomposing a compound is just to see, are there any familiar gases that you might be able to pull out or extract from that original substance? So when we're looking at ammonium carbonate, you could say, oh, well, there's ammonia in there. That's a common gas. Carbon dioxide is another common gas that you could pull out of there. So look for some gases like that when you're looking for decomposition reactions. You'll often get like oxygen as a product, right? More gases there. If you do see a carbonate that gets heated and is going to be decomposed. So this guy, if we're going to take some solid calcium carbonate and try and get that guy to decompose, those guys, the way that they always break up, they break up into carbon dioxide is always one of the products. And then a metal oxide, whatever that metal might be. So for this guy, calcium carbonate. So we have Ca plus 2 charge. Carbonate is CO3 minus 2 charge. If we were to heat that guy up, kind of loosen up those bonds within the calcium carbonate formula unit, and you kind of look in that calcium carbonate formula and say, are there any gases that I could kind of pull out of that guy? You'll always get carbon dioxide as one of the products. And then we have 3 oxygens on the left, 2 oxygens on the right. So where does that third O go? That extra O is going to combine with whatever metal is there, in this case, calcium. So calcium is a plus 2, that extra O minus 2, so calcium oxide. So this guy's already balanced. This process of forming carbon dioxide and metal oxide, it works no matter what the metal is. So if it was lithium carbonate breaking down, it would form lithium oxide. If it was sodium carbonate breaking down, it would form sodium oxide, and so on. If you see chlorates being decomposed, those guys are always going to decompose into oxygen gas and a metal chloride this time. So this example here, where we're going to take some potassium chlorate, heat it up. So potassium chlorate, K plus 1, chlorates minus 1, so KClO3. If we were to heat this guy up and make it decompose, you're going to get oxygen gas as one product. And then metal chloride, so whatever metal is there, in this case potassium, with the chloride ion. So K plus 1, Cl minus 1, we get KCl. Then we just need to balance the reaction overall, so our oxygens are out of whack there. And then 2 to fix our